Hello folks, welcome to Science Talk. I am your host, Jim Massa. In today's video, and one other video following this one, I want to discuss with you a topic I have previously covered on this channel, and that's namely plastics in oceans. And it's a major problem. Plastics are found everywhere in all the oceans of the world, from the Arctic Ocean all the way down to the Marianas Trench. So it's ubiquitous, it's everywhere, and it's a major crisis. And as I'll discuss in the second video, and a little later in this video, the threat and danger it presents to marine organisms. So how to reduce plastic pollution by billions of bottles? Refillables. So, to understand the widespread nature of this problem, we can just look at the beverage industry. Plastic bottles are being manufactured on a very, very large scale, with 445 billion liters of beverages packaged in PET bottles made and sold worldwide. What is PET? PET is a compound that stands for polyethylene terephthalate. Polyethylene terephthalate. And that's the great majority of bottles have that compound. They're made from that compound. Of that amount, the 445 billion liters, 21 to 34 billion, would it be, bottles are thrown away and they enter the ocean each year. And that's according to calculations made by the group Oceana. The resulting empty plastic bottles last basically forever, and they far outlive most marine organisms. So the title of a new report by Oceana is called Refillables, and it outlines how the plastic industry can take much needed action to reduce how much plastics gets introduced into the oceans. Now, kind of a side note, refillables is not a new concept. Refillable bottles were actually introduced by Coca-Cola in the 1940s. And basically was, and of course back then there were a lot of glass bottles. And I remember as a kid, you saved the bottles, you take them to the store, and it was like I think a 5-cent deposit. You returned it to the store, and they gave you a nickel for every bottle you brought back. So it's not a new concept, and it can be done. Now, what is interesting, however, is that refillable bottles are still a major delivery system for beverages in many parts of the world. So they account for more than 30% of beverages sold in major markets, including Germany, Mexico, the Philippines, and Indonesia. And this is from Anne Schroer, who is Senior Manager of Strategic Initiatives at Oceana, and she co-authored the Refillables Report alongside Matt Littlejohn of Oceana and Dr. Henning Wiltz of the Wuppertal Institute Circular Economy Division based in Germany. Now, unfortunately, with plastic bottles, places like the US, Canada, and some European nations embrace the use of plastic bottles, and those are major contributors of this problem. Reliable systems, going back to refillables, refillable systems are currently in place in 94 countries, and together these nations account for 80% of global sales of ready-to-drink water, soda, other non-alcoholic beverages. This is really encouraging, and this is something to take note of. Refillable bottle schemes have nearly a 100% success rate for getting the bottle back. So you return the bottle, and what happens to the bottle? You wash them, you sort them, and you reuse them. Refillable bottles are reused 20 to 50 times. 20 if it's a plastic bottle, 50 if it's a glass bottle. Refillable bottles also, as you would expect, can drastically reduce the number of single-use bottles that are being thrown out. When more beverages are sold in refillable bottles and the bottles are returned, the benefit to the ocean is amplified. Makes sense. Just a 10% increase in the share of beverages sold in a refillable bottle could result in a 22% decrease in marine plastic pollution. This would keep 4.5 to 7.6 billion plastic bottles out of the ocean each year. Refillable bottles can also be a climate-friendly option. Reusable bottles have a smaller carbon footprint than ones that are discarded after a single use. Dr. Henning Wills, who I mentioned just a moment ago, noted in a report that refillable PET bottles can save up to 40% of the raw materials and 50% of the greenhouse gas emissions that result from the production of single-use plastic bottles. So just 4 companies account for over 40% of sales in terms of revenue for the enormous non-alcoholic ready-to-drink market. So now what happens to all that plastic trash once it enters the ocean? Well, here's an interesting little story. When a U.S. Geological Survey researcher analyzed rainwater samples from the Rocky Mountains, he expected to see dirt, mineral dust, that kind of stuff. What he found was tiny flecks and fibers of plastic. Sometimes you get minute wind-blown plastics that will just travel across the globe. They're small enough, they're light enough, so they can be brought up airborne, and then they get on the wind patterns and the wind currents and deposited elsewhere. Plastic is everywhere. Air, water, food. We ingest plastics. We have plastics in our bodies. And this persists for a long time. It may break up into smaller and smaller particles, but it never breaks down into component atoms. You just break down into the polymers. That's it. Dr. Kim Warner of Oceana says plastic doesn't play nice with living things. While evolution has yielded a host of microbes, fungi, and invertebrates that can turn everything from wood to flesh back into CO2 and water, almost nothing can biodegrade plastic. And this is an important sentence that goes to the point I just made. The chains that make up the backbone of these different plastics are so complex that there's no organism out there that can effectively break down those chemical bonds in a natural setting. When plastic gets smaller and smaller, that doesn't make it easier to degrade back into its components. Not at all. Now here's some numbers for you. Of the over 8.3 billion metric tons of plastics that have been manufactured since 1950, only 9% have been recycled. And only 10% of what was initially recycled gets recycled a second time. So 9% is 0.09, and then you multiply 0.09 by 0.1, you have 0.009. So only 0.009 of all the 8.3 billion metric tons of plastic since 1950 has been recycled a second time. Extremely small amount. Some of the plastic waste is incinerated, but the great majority, 79%, ends up in landfills, landscapes, right? Look at the side of the road, for example, or rivers and oceans. Now, when exposed to sunlight, salt water, and the mechanisms of forces of water, winds, tides, etc., plastics will fragment into particles called microplastics, which I've already described to you as being 5 millimeters or less. Okay. Some of the microplastics can erode into the nanoplastics, which I described to you as being basically 0.1 microns in size on average. But all these tiny pieces, much of it winding up in places where it's not readily seen, well, it's not easy to see them in the first place. And when it enters the ocean, 94% sinks to the seafloor. Right? I did a segment some time ago, not too long ago, but some time ago, about plastics being found in Marianas Trench. So what does this do to organisms? Well, I will show you a photo in my next video of a desiccated corpse of an albatross chick, and where its belly should be is just a pile of plastics that it had ingested. Bottle caps, lighters, other plastic detritus, including some netting. The fatal effects of plastic on ocean animals is well known, but a recent study shows that even a few flecks of plastic can do great harm. On Australia's remote Lord Howe Island, tens of thousands of flesh-footed shearwater parents feed their chicks fish and plenty of plastic because the fish are ingesting the plastic. Some years, up to 90% of chicks have at least one piece of plastic in their stomachs. Scientists discovered that chicks that eat even small amounts of plastic suffer health consequences. Just one scrap of shampoo bottle or balloon is enough to trigger elevated cholesterol levels and blood chemistry associated with impaired kidney function. Needless to say, that's going to have detrimental effects on the organism. And of course, it's not just seabirds. It's everything. Everything that's out there, fish, invertebrates, everything is ingesting them. And of course, people are ingesting plastics as well. And we know it's harmful. We just don't know how bad the effects are. In experimental settings, plankton, marine worms, and fish that ate plastic consumed their real food less efficiently. Crabs that ate down plastics had trouble breathing. Ingesting microplastics slowed the growth of sea urchins. In an experiment that had very disturbing results, nanoplastics passed from a fish's blood into its gut and organs before crossing the blood-brain barrier, which then interferes with brain functions. Microplastics can act as a magnet for harmful pollutants like pesticides, flame retardants that enter the body. And this is a statement from Christy Levitt, who's head of Oceana's U.S. Plastics campaign. When they're eaten by fish, they may work up the food chain into our food supply. That is a process known as bioaccumulation, whereas whatever the pollutant is, as it works up its way through the trophic level, there is an accumulation in terms of concentration. You know, how many grams per milligram per kilogram of body weight, that kind of stuff. So we can get the bioaccumulation not only from, say, petroleum products, and plastic is a petroleum product when you come right down to it. In fact, another major user of plastics is the medical industry. You go to a hospital, you have an IV bag, that's plastic. The tubing that runs to your vein, plastic. A lot of things are plastic. You just use it once, you throw it away. In the old days, where you see those old movies with the glass bottles, you would have to sterilize those, run it in the autoclave, what have you. Well, perhaps we might need to go back to that. But then, of course, there's the issue of, well, to sterilize requires use of energy. No easy solution, is there? So according to industrial ecologist and researcher Dr. Roland Geyer, only 93% of plastic on average is the polymer itself. The other 7% are additives. These additives are complex chemicals, some of which are known to be hazardous. Now, is it possible to clean up all the plastics in the ocean? No. Let's just be blunt and honest. It's not. What we have to do, though, is reduce, if not eliminate, any more from being introduced into the system. So recycling what's already in the system is going to be difficult. Using refillables, reducing single-use plastic at its source is probably the best way to proceed. So, like I said, I wanted to bring you this report of what's going on. In my next video, I'm going to kind of get a little more specific with some data, and I'll show you a video and I'll show you a photograph. If you want to read up more of this topic, you can go to www.oceana, that's oceana.org, /blog, B-L-O-G, and a whole bunch of different articles will come up, as well as videos and so forth. So second video will follow next. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.